In this lesson, we are going to talk about angles within a circle as well as arcs. So go ahead and try the warm-up problems and then check your answers when you're ready. Number 1 should have gotten 14 pi or 43.98. Number 2, giving the diameters, we want to cut those in half. So AB would be, actually that is all the way to BF, so let me fix that. There we go. So AB should be 2 because all the way from A to F is a radius, which would be half of 5 or 2.5. And then this is 2.5 from F to G. And then we have some overlap here with the diameter being 6 for this circle G. And so that would make B over 0.5 right there. And that is your answer for BF 0.5. So in this lesson, we're going to talk about angles within a circle. And this one right here is called a central angle because it is got the vertex at the center of the circle. And it contains 2 radii that kind of form that angle. And the sum of all the circle, all the degrees, is 360. Whatever this angle is, it's the same degrees as our arc. So if, for example, this was 45 degrees, this arc would be 45 degrees. We can also add up our angles inside here, and the total again is 360. We can also look for half of a circle, a semicircle, and we know that's going to be 180. So on this example, we see that there's half right here. So we can just add up these 3 and set them equal to 180, and then we can solve for x. So adding 8x minus 4 and 13x minus 3 and 5x plus 5, we can add all the x's together, and that's going to give us 26x. We can add all of the numbers together, and that's going to give us a -2. And then we can go ahead and solve. Add 2, and then divide 182 by 26, which is going to give us 7 for x. And then we could go ahead and plug it back in if we needed to find any angles, but it does not ask us to do that on that one. Arcs are the connecting endpoints on the circle here. So this right here would be an arc. This right here would be an arc. Now this would be a minor arc because it is less than 180. And again, it equals that central angle. And then a major arc is a long one, and it usually has 3 letters. As you can see, we go from A, then to D, then to B. So we kind of follow the letters. And you can just subtract, if you know this angle, to from 360 to find what's left, if that is something that they give you values of. And then we kind of touched on semicircle, which is a 3 letters, and it's 180. So kind of tells you where to go. So on this next one here, we want to find, let's see, WC is a radius, and we want to identify X, Z, Y. So we go from X to Z to Y, and that would be a semicircle because it goes halfway, and we know a semicircle is 180 degrees. All right, so on the next one, we have going from, oops, does not like me, W, then Z, then X. So this whole outside area all the way here. So except for this one, which we know is 90. So we can go ahead and we know this is a major arc. And we're going to take 360 minus the 90 to get what's left, and that would be 270 degrees. And then the last one is just XW, which is this little arc here, which is going to be the same as the central angle. It is a minor arc, it's just the 2 letters, and it is less than 180. And so it's just going to be 90 degrees, the same as its central angle is the degrees of that arc. So now we can go ahead and actually find the degrees. If we've got a circle and we have percents, we can go ahead and take those percents and change them to a decimal and multiply them by 360. And so for KL, we take 21%, which if we change that to a decimal, we move the 2 decimal places to the left. So it is a 0.21 that we're going to take times 360, and that is going to give us our 75.6 degrees for KL. Next up is going to be N, and then J, and then L. So we're going to go from N all the way through J, all the way to L. So everything but the 9 and 7, which we know that 9 plus 7 is 16. So we're going to take, and we can either subtract find 16% of 360 and subtract that from 360, or we know that it's 100% and we can subtract our 16%, and what's left is going to be a 84. So we're going to go ahead and do a 0.84 times 360, because that's how much all these percents, you can just add them up to 26 plus 36, 26 plus 37 plus 21, and do it that way. And we get 302.4 degrees. And we can also use arc addition. So you can add up, just like you can add up the angles, you can add up the arcs. So we're going to find L, H, I. I don't know why it's using 3 letters for that one when it's minor, but looking at the fact that this right here is a diameter and this right here is 90, we know that these two together, those should add up to 90. And we always want to follow the order, so L to H to I. So the next one is I to J to K. And so I can see my semicircle right here, but we just have excluded the 32. So we know that 32, 90, and this one have to add up to 180. And so if we subtract our 90 and our 32, then we know that this is 58. And then we could just add the 90 and the 58 to get that angle. Or you can do your subtraction of 32 from 180. And get it that way. So 148 degrees. So this next part, we're going to kind of match up some of the vocabulary with its picture. And so for our minor arc, we know that's the smaller one. So either have X or we have Y, which X is going to be that smaller one, less than 90. So this one is our minor arc right here. And then our major arc is going to be that one. This one right there. And then this right here is our central angle. This angle right there, because it's at the center. And we already basically labeled arc. There's really no spot, yes, for arc. And then down here, we have semicircle is this right here. And so it's 180, right? And then we have either congruent arcs or adjacent arcs. Well, actually, it could be either on this one because these are definitely congruent arcs here and here. And then these are adjacent. These are technically also adjacent. And then if you look at it more of a 180 semicircle, this could technically be congruent arcs. But we'll go ahead and put the congruent here. Arcs for like this one and this one. And then adjacent being next to each other. All right. So the last thing we're going to find is arc length. Now, arc, we're looking at its degree, and it's the same as this degree, but the actual length, the measurement of this arc, we can find using our circumference formula times the degrees divided by 360. So here's our formula here. Again, this is circumference, and then this is just taking and finding kind of the percent that the degrees are out of 360. So for this one, we are going to find dA, which we have the degrees here is 40, so we put 40 over 360, times 2 pi r, which we know our r here, right there, is 4.5. So we can go ahead and do this in our calculator. Just make sure that you either have parentheses around this or you kind of do this 40 divided by 360 kind of in a separate calculation, and like do it first and then times it by all of these. So times 2 times pi times 4.5. And then we get 3.14. And nearest hundredth is 2 decimal places. So go ahead and try this B, example B, the last one on your own. You are finding dA, so be careful because you're not using 26. This is 26. So semicircle, subtract the 28, excuse me. So 180 minus the 28 to figure out what this degree is. So go ahead and try it and then set up your formula for arc length and plug it into your calculator. All right, and you should have gotten 152 degrees. And so 152 over 360 times 2 times pi times the radius, which is 6, and then typing that into your calculator, getting 15.92.